you almost need to write nothing, okay? Because actually P6 is exactly what we did in 8.1. So if you struggled with I numbers and I number operations, we did that in 8.1 before we did I number operations in trig form, and found some neat applications with it. So actually, you could go back to the quarter 2 calendar, which is on my haiku page, hit 8.1's notes and just peruse them real quick. And I'm just going to highlight some of the things, like what's I squared, everybody? A free -1. All right, and we remember that. And this is how you can write an I number in this format. Remember, square root of -4 is not -2. It's actually 2i. All right? You take out an I. And I'm not even writing these down. Don't even write them down. What do I simply do when it's this plus this? I add like terms. What happens when I have a subtraction sign? I distribute it. And then just real quick, what's the square root of -9? 3i, and then I'd add like terms. What's the square root of -81? 9i, then I'd add like terms. Oh, here we go. What's I squared? A free -1. We already said that. Then you'd add like terms. So you don't really need that one. Then remember we just said, so we can write it down again, I was made up as the square root of -1. So we could deal with square roots of negatives. There we go. There's a little symbol. All right? Therefore, I squared, you don't take a negative times a negative. What I squared does is eliminates the square root. Squaring and square rooting are opposite operations, so it frees the -1. And now it's not an I number anymore, it's a free -1. So, of course, this would be a FOIL. The difference between this and the last questions were there actually would be nothing there. There'd be no operation, right? You don't see a dot there ever. So no operation means I need to FOIL, but this actually doesn't show FOIL. This shows that other teacher that didn't allow FOIL, right? The distribution method of doing, distribute a 2 into the other one and then distribute a 3i, which is fine. I don't make fun of that. I just, you know what I do. But then the reason this is different than having an x in it is I squared is -1. So this really shows it perfectly what you have to do operationally to deal with an I number. In 8.1, we had a real hefty assignment. That was in December, right? It was like a month and a half ago in days. Not even a half, probably. So that's when we did 8.1, and we, you can look that up. I'm not even doing that one. I'm not doing this one, but I'll ask you again, what's the square root of -4? 2i. Well, then it's not even a FOIL, if I even can say that word, because what's 2i plus I? 3i. Then you just distribute a 3i. What's 3i times -5i? -15i squared, but that means it's what? 15, no I on it. It's magic. And then, okay, I'm just going to highlight this. And I don't understand why the students didn't get this. I raised to a power? Well, all we had to do was say I is made up as the square root of -1, and it's true. I wish I had the idea of who first did this. Give them credit, or her. So they did I equals square root of -1 so they could deal with square roots of negatives, and it created a whole different subset of math. It's really interesting, some applications with that I don't quite understand, but they're really neat. So I squared is -1, which we already talked about. This is where I get mad. Mad, I tell you. How do we not get what I to the third is then, when all it is the previous two multiplied together, right? And what's I squared? -1. -1 times I makes that -I. What's I squared again? What's -1 times -1? So I to the fourth is magically 1. And then what the idea is, I to any power would be one of these four answers. It'd either be I, -1, -I, or 1. And this is a big fat what? What is that number right there? That's a big fat 1. Because I raised to a power that is a multiple of 4 just means you have a bunch of I to the fourths multiplied together. Oops, I don't know what just happened there. There's that brain. What's 1 times 1? What's 1 times 1 times 1? What's 1 times 1 times 1 times 1? Do I have to keep doing this? Okay, what's 1 times 1 times 1 times 1 times 1? These are all 1, because they're all a bunch of I to the fourths multiplied together. All right, and then over here, I to the fifth is I to the fourth times I. All you have to do is have some minor knowledge of exponents. What's I to the fourth? 1 times I is I. Blah, 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 blah. Then I talked about you can type this on the calculator, but at some point the calculator overloads and does what kind of is a calculator error. So negative 3e, negative 13 minus I is actually 0 minus I. The calculator just can't write 0 anymore. It is a calculator malfunction. Not a malfunction, it's a calculator minor error to the 13th decimal place. Because that's what negative 3e, negative 13 means. And we've talked about that before. I don't want to talk about it anymore. Dividing. We didn't do this last hour. I just highlighted. How do I rationalize a denominator that is 3 minus I? I have to multiply by what's called the what? What's the term? Starts with a C. I don't know if I heard it. There's a J in it. Conjugate. I couldn't hear it. I got my earphones on if that's what you were saying. We didn't want to go through that math. I'm not even... I assigned 1 just to remind you of that. We've already done it. Don't worry about these types of questions. And then all I'm going to do is bridge back to P5. All right? Remember that you could use the quadratic formula to solve a quadratic. Sometimes you end up with the square root of a what? Negative. And what do you got to do with that square root of negative? Make it a what kind of number? Imaginary. So now that leads me to this section. P5. Wait, P5 is before P6. Because I wanted to bridge using the quadratic formula to solve a quadratic, you could get an I number. So that's how these are kind of intertwined. There are some things you better be aware of, though. Okay? And you did this a lot with Math 2 and or Math 3. I think it was really Math 2 because I taught that class. And I remember we spent almost 2 months on quadratics. I really do. Graphing them, factoring them, and then other methods of solving quadratics. Now here they are. The fifth one, this is what I'm worried about because there is some graphing calculator stuff. It is actually required in this class. All right, so I know some people said they lost theirs. I know I didn't let you use it on the final. But there are some applications throughout the year that you need to know how to solve using a graphing calculator. I'm not going to be able to teach you that today. I didn't assign anything. This is just an option anyway. Any quadratic can be solved by any of these 4 methods by hand. It's possible. This is just a nice attribute. Then sometimes there's a rare quadratic or cubic, and later that's when we're going to teach the calculator, that you might have to use a graphing calculator only because the answers are so irrational, all right, that they're not even square root answers. Okay, so factoring. What's ZPP stand for? Zero product property. You got it. This is a key. You must use this to be a efficient student that gets quizzes done fast. And I'll go through that when we show the examples with the work already done because of the time that we have. And then you can, for any question, always use the quadratic formula if you have a quadratic. And then you could graph using a graphing calculator. We'll talk about that later when it actually works and when it doesn't. So last year I did a graphing calculator example. We'll wait on that. No graphing calculator stuff today, even if you know how to do it, if you've ever seen it before. I bet you have. Okay, here's the smattering of work of doing this through factoring. The good old-fashioned MA method, which you may or may not need. Some people can just look at this. By the way, good whats are good whats? Good factors are good FOILers. The good FOILers don't need any of this. They could just sit there and say, okay, I have 4x squared minus 8x plus 3. I bet you it's going to be 2x and 2x that equal 4x. I have a negative middle term. My only options are negative 1 and negative 3 multiplied to 3. And then they're able to shovel, the numbers in there and see that it foils out. But it is nice to have this tool when you can't unfoil. Good old-fashioned MA. 4 times 3 is 12. What adds to negative 8 and multiplies to 12? Negative 2 and negative 6. Split up the middle term to negative 2 and negative 6, and this is the smartest thing to do in the world. Don't make this minus 6x. Make it plus a negative already, then group the negative in there. Now I crossed these off because I told last hour these are like terms. And factoring by grouping only works if these parentheses are equal. These parentheses will be equal if you pick the right MA numbers. If you do not pick the right MA numbers, that's where you get that error, and you better reassess that. Okay, but anyway, you pull out the 2x minus 1. That leaves you with the 2x minus 3. Then you go and use the zero product property to solve for x, which we did do with trig. Does anyone have any questions so far? There's a blank product property. What's the blank? 0. Is there a 20 product property? Do you know how many people are going to do this on a test when I do this exact kind of question? Too many. It makes me cry. So what do I have to do for this one in order to solve it? I just gave you a hint. It's up there. Distribute. What do I do with the 20? Subtract. And then factor. Now negative 20 is kind of a big number. But I'll give you a chance to write this down if you want. So you can't do the 20 product property. You can. Your answers will be completely wrong. They won't work. You okay? Sometimes you make a face. All right. So then distribute, subtract, and then factor. MA is kind of tough. Numerate people figure out what multiplies a negative 16 adds to 11. Someone last hour, bam, right away. Sometimes that's the problem with factoring. You don't know your factors. You don't know how to break down numbers well, and it takes some time. You can use a calculator for that as well, though. Then I told last hour you should be able to use the zero product property real quick. Add 4, divide by 3. Oh, subtract 5. That's easy. And that's what these solutions are once you get the factors. Okay, now, here's the thing with this one. This is what I'm talking about students that take too long on a test. I'm not saying you're wrong, but I am saying you're wrong for taking 8 times as long in this question than you should. The students that don't finish a test take 2x minus 1 and FOIL it. Then they subtract 9 and then try to refactor. What if it's not factorable? Then what do they have to use? Quadratic formula. This is all a lot of work that takes some time. Then they get their answer. When really all they could have done is done what to both sides? 2x minus 1 squared. What's the opposite operation of squaring? Square rooting. Don't get burned. Square root of 9 is what? Plus or minus 3. And then what you have to do is set up 2 possibilities. So when a question presents itself in this manner, you certainly should not FOIL, subtract, and then refactor. That is 8 times as long as square rooting both sides and then solving both leftovers because of the plus minus. It's really 8 times as long if this was not factorable after you did that. Then the quadratic formula, all that takes time. And I get students do that all the time. So it's all about picking the best efficient method as well. Okay, again, for just a real quick notes, because I got to talk to you about your classes. Maybe I'll erase this one. I just spit on the screen again. Ugh. Sorry, and I put that on the internet. Okay, just to kind of incorporate this with the last section. I made this negative 25. So 4x squared equals negative 25 is the question. Okay, first things first, you should not square root both sides until you get x by itself. Again, with these just quick notes, because we got some stuff we got to do, just do that. Then square root both sides. And the reason I did what I did here is, maybe I'll make this one big line there. X equals, what happens when you square root both sides? Plus or minus, 2 answers. And then what's the square root of negative 25? 5i. What's the square root of 4? 2. Okay, that's how you break that down. I guess that's good enough. So, even in this process of solving by square roots, you could get an I answer. And then I talked about this with the other class last hour as well. No, you don't square root both sides until you get the square by itself. So you do want to divide by 4. By the way, what's 18 over 4? Reduced. 9 over 2. Do you know why I didn't do that? Why did I not do that? Because I knew, I don't have time, I knew I'd eventually have to square root. and the square root of 4 is a perfect square. So if I made it 9 over 2 and then square rooted, then I'd have to re-rationalize. I'd have to rationalize the denominator. Are you okay? You're looking, you have a quizzical face. Okay. So, and then the next thing is, what's 18? A number. What times what is 18? 9 times 2. What's the square root of 9? 3. So I went ahead and started simplifying this. This is not an I number because it's not square root of a negative. So just be putting I's where they don't belong. And then you end up getting that. And then the last thing, I'm just going to show this because this is not new. This was in 8.1. We did the quadratic formula in 8.1. We're not going to complete the square. We'll do it later. When actually we do conic sections is what it's called, when it actually has a nice application. But I will say this. You might want to write this down for your notes. I'm going to zoom this back just to remind you what the quadratic formula is. The process of completing the square on ax squared plus bx plus c creates the quadratic formula. And I have done it in the past where I showed the students, and it's mind-blowing. It's actually kind of tough mathematics. You'd have to learn the process of completing the square before you could understand how we get the quadratic formula. But that's fine. And then just be aware that if I use the quadratic formula, I could get an I number. But I don't have an example that shows that right now. So you have to have the ability to plug in the numbers, simplify the numbers correctly, and then maybe get the decimal out of the numbers, which happens in number 19. And then just bear with me. I'll let you take this down. I'll leave this up here. What if this said 8 minus 9 in here? What's 8 minus 9? Negative 1. What's the square root of negative 1? So this would be 3 plus or minus I over 4. So even in the quadratic formula, you could get an I number answer. Okay? And assignment's real simple, real basic from P5 and P6 in your book.